Hey there. So I think the target for this lesson is pretty clear just by looking at the title. We're going to work again on probability. We did, I think, just one lesson earlier this year on probability, but now we're going to get into it just in a little bit more depth. All right, so probability is the measure of how likely an event is. I like to define it as what will probably happen, and you can see probability and probably have the same root. All right, so let's take a look at this first example. A spinner has 4 equal sections, red, yellow, green, and blue. So the first question here is, what is the probability of spinning yellow? And this capital P does stand for probability, and it's always the probability of what's going to happen that's inside the parentheses. In the second question, I want to know what is the probability of spinning yellow or blue? Spinning yellow or blue are called mutually exclusive events. We'll talk about that on the next slide. But I want to remind you real quickly how you find probability. Probability is simply a fraction. All right, so here's this event. We're calling it A. So it would be the number of ways event A can occur over the total number of possible outcomes. So spinning yellow would be, what is the probability of spinning yellow? How many times can that occur? Well, that's only one section. So it would be 1 out of the total number of outcomes. So it's going to be 1 out of 4. All right, let's take a look at the next slide. Because one thing that happens in probability is probabilities are often expressed as percents. So what I like to have students do is express your probability as a fraction, then change it to a decimal and a percent. So the probability of spinning yellow is 1 out of 4. It's really just a fraction of this that is yellow. And then that becomes 25 hundredths, which is 25%. This one, what is the probability of yellow or blue? Like I said before, those are mutually exclusive, and mutually exclusive events are events that cannot happen at the same time. If we have mutually exclusive events, another word for that is compound events because it's more than one event occurring. But in this case, if they're mutually exclusive, we can just use this to help us solve it. So yellow and blue, well, that's 2 sections over a total of 4. So basically, I just wrote the fraction 2 over 4, reduced it to 1/2. That becomes 5/10, which is 50%. And you can see just by looking at this, we have a 50% chance of getting yellow or blue. All right, so let's try this one, rolling a die. All right, so I'd like to have you pause the video and give this one a shot. A single 6-sided die is rolled. We're going to assume that everything today that we talk about is fair. So let's say it's a fair 6-sided die. What is the probability of rolling a number greater than 4? All right, so pause the video and try and figure that out. And when you're ready, start the video going again. All right, so hopefully you got the same thing I did. So the probability of rolling a number greater than 4 is 2 out of 6. That's because there are only 2 possibilities greater than 4, and that would be 5 and 6. So 2 out of 6 reduces to 1/3. That becomes this repeating decimal, 0.333 repeating. And I'm rounding my percents to the nearest tenth today, so that becomes 33.3%. All right, so I talked about compound events in a previous slide. That's when more than one thing is happening. Mutually exclusive events can happen at the same time, but now we're going to go to a new type of event called independent events. Independent events are events that can happen at the same time, but do not have any effect on each other. All right, so mutually exclusive cannot happen at the same time. Independent events can. All right, so here's an example of an independent or 2 independent events. Let's suppose we have a spinner with 4 equal sections and we have a fair 6-sided die. These 2 events are independent because they don't affect each other. It does not matter what I spin here. It's not going to affect whatever I get on the die, and vice versa. I can get like 2, 4, whatever over here. It's not going to affect what I get on the spinner. All right, so here's the question. What is the probability of getting green and an even number at the same time? All right, so let's take a look at this. All right, so what I'd like to do is introduce you to the term sample space. In statistics, a sample space is a set or a list of all of the possible outcomes. So I've set up the sample space in this situation as a table. It's very common to set sample spaces up as a table. So I put the possibilities with the spinner across the top, the die up and down, and in the middle here, I've listed all of the possible combinations. So I think you can see by looking at it how I've organized. I think you can also see there are 24 possible outcomes in this situation, all right? All right, so then the question was, what was the probability of getting green and an even number? Well, I took a look at my green column and I figured out which ones were even, and it's just the 2, the 4, and the 6. So what I have then is 3 out of 24 that satisfy those conditions. So when I set up the fraction, it's 3 out of 24. I reduce that to 1/8. That makes my decimal 125 thousandths, and then I have a percent of 12.5%. So really not great odds here, but it does give you an exact amount to go on. So this is what would probably happen, not very likely. Another way sample spaces are often set up is as tree diagrams, right? So I think you can see why it might be called a tree diagram. So this is how we do this. We put all of the possibilities for one of the events in a column, and then we branch out and add the possibilities for the second one, but we have to do it each time. So when I roll a 1, I could then spin blue, green, yellow, or red. All right, so that's all of the possibilities when I have a 1. Then I just keep repeating the colors for each one. It's really the same way, the same data that shows up in the table. It's just a little bit of a different format. So I could get 1 in blue, 1 in green, 1 in yellow, 1 in red, 2 in blue, 2 in green, 2 yellow, 2 red, all right, etc. You can see there are still 24 possible outcomes, and whatever is in your last column will tell you how many outcomes there are. And I've put arrows on each that would be an even number and green. And it's the same answer, of course, same information. So it's just a different way of setting up a sample space. Okay, so the question is there a more efficient way? And of course there is. So I hope you sort of have been thinking about that a little bit as I've been showing the video here. Looking at the sample space is kind of like using algebra tiles. It's a good visual. It's not necessarily efficient, right? But I'm going to hopefully show you by using the sample space why this method works. All right, so let's start by thinking, all right, what are all of the possibilities in terms of rolling a die? So it's 2, 4, and 6, so 3 out of the 6. So I've shaded in all of the possibilities. I think you can see that that really does end up being 12 out of the 24 when you're also counting in the colors here. It's really half of it. So half of the time, I'm going to get an even number. So that really does end up being 12 out of the 24. All right, but then when you add this second condition, that would be getting green and getting an even number. Well, you can see I've shaded this in, this column. This is going to be 1/4. But what I really need to find out in order to figure out, all right, what's the probability of both of these things happening is what is 1/4 of basically the half, right? So these yellow ones are half, and then 1/4 of the half would be these blue ones right here. So if you just think about just these yellow pieces, let's just pretend the white pieces were taken away, then you can see, oh yeah, these blue ones are 1/4 of that half. Right, so then that ends up just being 3. So these ones that have this little orange in the blue, the things that are in the blue, it's really 3 out of the total 24. All right, so here's how we can do this more efficiently. Remember, of means to multiply. Right, so what we just figured out is what is 1/4 of the 1/2. And when you multiply those together, that gives you 1/8. So 1/8 of this satisfies both of those conditions. Again, here's your decimal, here's your percent, same answer. So the efficient way to actually figure out the probability of independent events occurring is to find the probability of each separately and then multiply them together. So here's the probability of spinning green. Here's the probability of getting an even number. When I multiply them together, I get the probability of both of those occurring. Now remember, this is what you use when it's independent events. All right, what I'd like to have us do is just try this one. So this is an independent event because you're replacing the marble. But what I'd like you to do is just read this on your own. And remembering that these are two independent events, try to solve this and give your answer as a fraction, a decimal, and a percent. All right, so I hope you got the same thing I did. There are a total of 16 marbles. 5 of them are green, 6 of them are yellow. So I figured out the probability of getting green first. That's 5 out of the 16. And then the probability of getting yellow, 6 out of 16. Multiplied them together. All right, so that's 30 over 256. I reduced that to lowest terms, 15 out of 128. And then I used my calculator to determine the decimal. This one's rounded to the nearest thousandth. So that gives me about 11.7%. Again, not that great, but still, it could happen. All right, now what I'd like you to do is try these 4 on your own. All right, just a couple of situations I think I need to clarify here. Just keep in mind a standard deck has 52 playing cards. There would be 5, for the 5s, there are 4 cards with 5s, 1 for each suit. And there are 4 kings. So you just need to know 4 5s and 4 kings all together. I think you can do the rest without any explanation. So stop the video, try solving these 4, and then come back and check, see if your answers match mine. Okay, so I hope they match. All right, so the first one is 6 out of 11. There are 6 odd numbers when you number 1 through 11. So that ends up being 54.5%. A little bit better than half the time. In terms of these cards, you've got 4 5s and you've got 4 kings. These, by the way, are mutually exclusive events. They cannot happen at the same time. You can't pull out a 5 and a king. So that's why you can think about them all together. So it's 8 out of 52, reduces to 2 out of 13, and that boiled down to 15.4% chance of doing that. Right, with the glass jar, this is just one single event. So there are a total of 22 marbles, 6 out of 22. That reduces to 3/11ths. So that becomes 0.272, 27.2%. All right, now down here with the socks, what happens is they're asking what is the probability that you'll pull out a pair of red, and then when you put the socks back in again, you'll pull the red pair again. Right now, the idea is this is completely random. Right, these are independent events. Whatever happens the first time you pull socks is not going to affect the second time you pull your socks. So it's 1/5 times 1/5, which ends up being 1 over 25. The decimal for that is 4 hundredths, which is 4%. Pretty unlikely to occur, right? I hope you got these all right. If you had any trouble, let me know. And just send me an email and I'll try to help you out. Next, I just want to let you know that I used this website quite a bit to produce this lesson. It's mathgoodies.com, and sometimes it's referred to as Mrs. Glosser's probability page. If you're interested, visit that page yourself. She's got some great quiz questions on there, and some of the questions that I used, I pulled from her site. All right, so I needed to cite that source so that I'm not plagiarizing. I want to give credit where credit is due. All right. Hey, nice work, everybody. Have a good weekend. That's the important thing.